Okay, so this question is a length, area, volume, scaling factor problem. And I'll show you exactly how to do it. If you don't know how to do these questions, they can be pretty difficult. But if you know the tricks, then it's easy, I promise. Okay, so we've got this small model. We're told that the base area is 6 centimeters squared and it weighs 2 kilograms. It's going to be scaled up, and this guy's making a statue. The base of the statue is that 253.5 centimeters squared, and we have to work out what it's going to weigh. Okay, now this is how to do it. We've been given the area, okay, of the two bases, which means we can work out the scale factor from going from there to there of the area, okay? So let's start with that. Area scale factor is, you just divide the big one by the little one, okay? That's 253.5 divided by 6, okay? And that turns out to be 42.25. Okay, so that's the first thing to do. Work out the scale factor of whether it's the volume, the area, or the length, whatever they've given you. In this case, they've given us the areas, so work out that scale factor. So we've got the area scale factor, 42.25. Next, we can work out from that what the length scale factor is. Okay, there's volume, area, and length. Okay, length is one-dimensional. It doesn't mean a particular length, such as the height or the width of the base. You can think of it as more general, more abstract than that. Just some length. Okay. When you measure length, it's one-dimensional. Okay. When you measure area, it's two-dimensional. Volume is three-dimensional. So if we're dealing in centimeters, which we are here, the units for length would be centimeters. Units for area would be centimeters squared, like here. And of course, for volume, it's centimeters cubed. Okay. So having found the area scale factor, you then have to go down to here and find the length scale factor, right? Now, when going from area to length, you take the square root, okay? So, therefore, the length scale factor is the area scale factor it's the square root of that, okay? So go from there to there, take the square root of the area scale factor. So that is the square root of 42.25, which turns out to be 6.5. Okay, so that was the second step. Find the length scale factor, right? So the area scale factor was 42.25, the length scale factor is 6.5. And now, having gone from the area to the length, we're going to go from the length to the volume to get the volume scale factor, because the mass, I'll talk about this a bit more in a minute, but finding the mass of this, it's proportional to the volume. So we're essentially looking for the volume. Okay, now going from length to volume, you take the length scale factor and you cube it. Okay, so from here we say therefore the volume scale factor is the length scale factor cubed. Okay? Which is 6.5 cubed, which turns out to be, where are we? 274.625. 274.625. Okay, so that's a third step. Okay, first step, find the area scale factor. Second step, find the length scale factor by square rooting. Third step, get the volume scale factor by cubing the length scale factor. Okay, so we now know that the mass of this thing, well, okay, no, let's not say mass, let's say the volume of the statue is 274.625 times larger than the volume of the model. Okay? Now, but we're not talking about volume. Well, we are. It's just that in the question they're talking about mass. Okay? Now, like I said, the mass of these things is directly proportional to the volume, okay? Because the density is the same. This is a bit of physics, right? Density, shall I go into this? No, I'll just say it. Density is mass over volume. Yeah, okay. Look, density is mass over the volume. Okay? Bit of physics. So, density is mass over volume. Therefore, mass is density times volume. Okay? Now, the point is that these two have the same density. That's the same for both of them, because they're made of the same stuff. This clay that this guy's buying. And so for, so for both of them, D is the same. That's just a constant. So for both of them, the mass is directly proportional to the volume by the same constant. And therefore, the mass, we can treat it like volume. Okay? So therefore, if the volume of the statue is 274.625 times larger than the volume of the model, therefore the mass of the statue is also 274.625 times the mass of the model, which is 2 kilograms. Which is, stick it in the calculator and you get 549.25. 549.25 kilograms. Okay? Now, that's the how to do these sort of questions, okay? But in this particular question, they want to know how many bags of clay you should buy. It's just a little bit, make it slightly more difficult at the end. Well, apparently there were 10 kilograms in each bag, so you're going to need 55 bags. Because 55 bags times 10 kilograms is 550 kilograms, which is just enough. So 55 bags. Okay? Right, good. So I'll just finish off by going into this in a bit more detail. Your objective with these sort of questions is to find the length scale factor, okay, which in this case was 6.5. In some questions, they may give you the volumes of these two things, and they might ask you to find the area of the larger one. In which case, you'd have to start with the volume. You always go down to the length scale factor first, and then you go up to whichever one you want. So for this question, we were given the area. We worked out the area scale factor. We went down to length to get the length scale factor, okay, and then we went up to volume to get the volume scale factor. But if they give you the two volumes, work out the volume scale factor, go down to the length scale factor and you would do the opposite. To go from volume scale factor to length scale factor, you would take the cubed root. Okay? Going in this direction, from length to volume, you cube. But going from volume to length, you would take the cubed root. And then going from length to area, you would square it. Having found the length scale factor, to get the area scale factor, you would square the length scale factor. Because in this case, we went from area to length, which means taking the square root. But going from length to area, you would square it. Okay? So, in a different colour, in blue is this particular question, okay? But in pink, the general case. This is scale factors, right? Going from, where can I fit this in? I'll do it here. Right, okay, let's start with there. Area to length is square root, okay? Going from there to there, from volume to length, is you take the cubed root, okay? Going from length to area, whatever the scale factor is, you square it, okay? The length scale factor, you square it. And going from length to volume, whatever the length scale factor is, you cube it. Okay, so that's the general case in pink. Right, I'll leave it there. I hope that helps.